Hello and welcome. Today, we're going to explore something truly out of the ordinary. What would you think if I told you there are 5 dark mysteries suggesting that the solar system may not be as safe as it seems, hidden within a colossal structure that has operated for billions of years under continuous silent pressure? Millions of kilometers separate us from the boundaries where time appears to freeze in ancient orbits. How can we trust our stability if the sun itself still conceals phenomena that challenge human logic? Our journey begins with Planet 9, something too massive to ignore and too elusive to confirm. Then we move to the unsettling black sun, a sign that even our star is not fully understood. We pass through the history of massive impacts, continue toward wandering black holes, and conclude with the dark forest theory, where existing without being noticed may be essential. But before we continue, I'd like to invite you to support this work. If this kind of exploration resonates with you, consider subscribing to Cosmos for Rest and sharing it with others who appreciate calm, thoughtful science. Your support helps sustain the creation of these journeys through the universe. Now, allow yourself to relax, gently close your eyes, and let science guide you. To understand the magnitude of what surrounds us, we must first let go of the idea that the space around us is a static and perfectly safe setting. Can you imagine what it would feel like to drift through absolute emptiness, sensing only the subtle and relentless pull of gravity, while billions of years of history unfold in profound silence? The story we learn in books often presents a neatly ordered solar system, with planets moving along, invisible tracks in what seems like eternal harmony. But scientific reality invites us to walk through far more complex and at times unsettling paths. This might seem hard to believe, but the sense of peace we feel when looking at the night sky is rooted in our extremely short human timescale. On astronomical scales, our cosmic neighborhood carries a biography marked by monumental events and transformations that challenge our sense of security. Everything we know today, from the gentle breeze on Earth to the dust storms on Mars, is the result of a gravitational dance that began more than 4.5 billion years ago. In that primordial time, there was no order, only a chaotic disk of gas, dust, and molten rock colliding at unimaginable speeds under the influence of a young and temperamental sun. Can you imagine the pressure and heat of an environment where entire planets were being forged through fire and impact? The solar system was not born to be a place of rest, but rather a laboratory of extreme forces. Over the ages, gravity acted like a strict architect, clearing orbits and organizing matter. But this organization was never absolute or final. The dark history of the solar system reveals that behind the facade of stability lie deep scars and mechanisms that can still alter the fate of entire worlds. Nothing we discuss here is treated as an immutable certainty, but rather as a set of scientific hypotheses, statistical risks, and real observations that help us understand the less predictable side of our existence in space. Let's consider now the idea that space is not just emptiness, but a dynamic fabric where invisible masses may be hidden, waiting to be discovered. We often assume we know all the major inhabitants of our neighborhood, but modern science warns us that our map may still be incomplete. It is both fascinating and humbling to realize that we live within a small bubble of light, protected by the sun's magnetic shield, while beyond the known orbits, the unknown reigns in temperatures approaching absolute zero. The vastness between planets is so immense that sunlight takes hours to reach the edges of the system, and it is in that darkness that the shadows of doubt begin to emerge. This might seem hard to believe, but the orbital harmony that now feels so natural is actually a tense balance achieved after billions of years of planetary ejections and catastrophic collisions. The solar system we mentally explore today is only what remains of a much greater gravitational battle. Many worlds that could have existed were cast into deep space or consumed by the sun in its violent youth. So when we say the solar system may not be entirely safe, we are recognizing that the same dynamism that created it is still present, operating on timescales we can barely perceive. Can you imagine being on a ship in seemingly calm waters, knowing that the deep currents below are the same ones that caused shipwrecks in the past? This is the mindset science invites us to adopt when facing the cosmos. It is not about fear, but about a deep respect for the complexity of physics. As we begin this journey through dark mysteries, we must remember that the silence of space is not the absence of activity. It is the stage where events unfold slowly and majestically, far beyond our immediate perception. Gravity, that invisible force keeping your feet on the ground, is the same force governing the motion of trillions of objects in the Kuiper Belt and the Oort cloud. It is the thread that connects this entire story, the hand that organizes and, at times, disrupts the environment where life has emerged. Feeling this connection between the local and the universal helps us understand why mysteries like Planet 9 or the Dark Forest theory are not just curiosities, but essential pieces in understanding our own survival and our place in the galaxy. At this moment, I invite you to imagine the sun not merely as a point of light, but as a colossal engine of plasma, whose internal secrets may generate anomalies we are still struggling to explain. It is the heart of the system, but even the strongest heart has rhythms and variations that can surprise the most attentive observers. Science is driven by this desire to understand what is hidden, to look into the darkness, and find patterns where others see only emptiness. Exploring these frontiers of knowledge requires humility because, as we will see, even images captured by the most advanced space agencies can spark intense debates and interpretations that challenge what we believe to be reality. We are only beginning to scratch the surface of a story far older and more complex than any human narrative. The solar system is our home, but it is a home built within a vast, ancient, and occasionally hostile territory, where each discovery reminds us that absolute safety is a concept nature rarely recognizes. As we continue this exploration, feel the calm of being in a space of learning, where each scientific insight becomes a light we cast into the unknown. Can you imagine the patience required to monitor the sky for decades, searching for an invisible giant that reveals itself only through its gravitational influence on other bodies? It is with that same patience and attention that we will move forward, understanding that the cosmos is a book whose pages are written in light, gravity, and time. Prepare your mind to understand that the balance we experience today is a temporary gift of physical laws, and that studying the dark history of our system is, above all, a celebration of human intelligence, an intelligence that dares to question the darkness in search of truth. This journey is only beginning, and what we discover together will take us from the depths of our sun to the silent boundaries where light can barely reach, revealing that the beauty of the universe lies both in its brilliance and in its deepest, most profound mysteries. Now that we understand the volatile nature of our cosmic cradle, I invite you to imagine a silent journey beyond the orbits we've known since childhood. While the inner planets follow their routine of light and warmth, there exists a region of deep shadows and absolute cold, where motion is governed by something we cannot see, but can feel through its physical influence. We are speaking of the outermost boundaries of our system, a place known as the Kuiper Belt, where trillions of icy and rocky bodies drift in near total isolation. This might seem hard to believe, but it is precisely in this frozen desert that we find clues pointing to a massive and invisible resident that appears to shape the architecture of the entire outer solar system. Can you imagine what it would be like to exist in those depths, where the sun is nothing more than a bright point in eternal darkness? In theory, the motion of these distant objects should be random and disorganized, following no clear pattern. Yet, astronomers have noticed something deeply unusual. The most distant objects in the solar system, those far beyond Neptune, exhibit strangely aligned orbits, as if they were being guided by a monumental force compelling them into a shared choreography. It is as though an invisible conductor is leading an orchestra of ice, and that conductor is what we call Planet 9. The existence of this hidden giant at the edge of the solar system is not just a loose theory, but a conclusion drawn from the observed behavior of other celestial bodies. Imagine a mass possibly 5 to 10 times that of Earth, orbiting the sun at such an immense distance that a single year there could last between 10 and 20,000 Earth years. That means that while entire civilizations rise and fall on Earth, this giant may not even complete one orbit around the sun. Can you imagine gravity operating with such patience across such vast stretches of time? Planet 9 exists in isolation, following an elongated orbit that rarely brings it close to the inner system, remaining instead in the distant margins where light is only a faint memory. Feeling the presence of this planet is to understand that our solar system still holds a hidden life we have not fully mapped. Observational routines suggest that this world may have influenced the tilt of all the other known planets over billions of years. This might seem hard to believe, but even our own position in space may be subtly shaped by this unseen neighbor. It is not a direct collision threat, but its existence proves that we do not yet fully understand our own cosmic backyard. There are enormous masses concealed in the darkness, capable of altering paths and destinies without ever being touched by a beam of visible light. Now imagine the internal pressure and composition of such a world. Being so massive, it likely retains internal heat from its formation, energy that struggles against the deep cold of space. If we could move through its atmosphere, we would feel colossal winds and an immense gravitational pull shaping every layer of its structure, whether gaseous or rocky. The existence of Planet 9 is a constant reminder that our sense of safety is limited by what our current technology allows us to detect. It is out there, moving silently, pulling the invisible threads of gravity and keeping the objects of the Kuiper Belt in their designated paths. This gravitational influence is the language through which the solar system communicates with us. When we observe the unusual tilts and orphaned alignments of these distant icy bodies, we are reading fragments of a story written over countless ages by this hidden planet. Can you imagine the magnitude of an object that, even without being directly observed, can impose its influence over trillions of celestial bodies? It is a pure manifestation of physical power, a quiet dominance that unfolds far from any human witness. The search for this world stands as one of the greatest scientific investigations of our time, combining mathematics, physics, and a curiosity that refuses to accept emptiness as an answer. As we come to understand the rhythm of Planet 9, we begin to realize that the solar system does not end where traditional maps suggest. There is a vast and mysterious cosmic suburb where physics operates more slowly, but no less relentlessly. The behavior of these distant objects teaches us about the resilience of matter and how gravity can organize chaos even under the most extreme conditions. Imagine the absolute silence of that region, interrupted only by the majestic passage of a giant carrying the secrets of our system's formation. It may be a planet that was expelled from the inner regions billions of years ago, or perhaps one captured from another star system that once passed nearby. Regardless of its origin, the routine of Planet 9 is an essential part of what makes the solar system a dynamic, and as we've seen, not entirely predictable, environment. The presence of invisible masses operating in the shadows suggests that the architecture of our cosmic home is far more complex than the stable, circular orbits we often imagine. This might seem hard to believe, but the balance that sustains life on Earth depends on a web of gravitational influences, stretching across trillions of kilometers. Feeling this connection reminds us that we are not isolated islands in space, but part of an interconnected system where events in the deepest darkness can echo across the entire structure. Can you imagine the moment when a telescope finally captures the faint light of this distant giant? Until that day arrives, we live with the mathematical certainty of its influence. Astronomers carefully examine every fragment of data, searching for a needle in the cosmic haystack, while Planet 9 continues its silent journey, indifferent to our urgency and our questions. It stands as a guardian of the outer boundaries, a reminder that the universe always holds something more, a reserve of mystery that keeps us humble and attentive to the vastness around us. Thinking about this region allows us to feel the immense scale of astronomical time. Where Planet 9 resides, time is not measured in days or months, but in millennia. Its motion is a lesson in permanence. While Earth's surface is constantly reshaped by oceans, winds, and life itself, this distant world remains almost unchanged in its frozen isolation, preserving within it the original conditions of the nebula that gave birth to everything we know. It is a gravitational time capsule, a giant breathing slowly in the vacuum, guiding the smaller travelers of the Kuiper Belt in an endless dance. This might seem hard to believe, but if this planet did not exist, the orbits of distant objects would be entirely different, and perhaps the stability of the inner solar system would not be what we experience today. Gravity is a balance, and every component, no matter how distant, contributes to the overall harmony of the system. Understanding the presence of Planet 9 is, therefore, a way of understanding a fundamental part of ourselves and the safety we often take for granted. It proves that the solar system still holds many shadows waiting to reveal truths about the nature of reality. Let us continue this journey, carrying the weight of this discovery, while allowing our minds to expand into dimensions where mathematics meets reality. Planet 9 is the first of our 5 mysteries, preparing us to understand that what we cannot see can be just as real and influential as the sun that warms our skin. It is at this boundary between the visible and the invisible that science finds its greatest purpose, and it is toward that boundary that we now continue, with the calm certainty that knowledge is our most reliable protection against the darkness of the unknown. Now that we have traveled through the frozen boundaries where Planet 9 exerts its invisible sovereignty, I invite you to turn your attention back to the pulsating heart of our solar system. Can you imagine standing before a colossal engine of plasma, a sphere of fire so vast that it could contain more than 1 million Earths within it? The sun is our source of life, the gravitational center that holds everything in place, but it is also the stage for phenomena that challenge our understanding and reveal how much we still have to learn from nature. This might seem hard to believe, but even the star we study daily with the most advanced instruments continues to produce mysteries that spark deep debates among the world's leading experts. Let us now explore one of the most intriguing episodes in modern astronomy, recorded through scientific data collected in the years 2012 and 2016. During those moments, sensors monitoring solar activity detected something unusual and monumental: a dark sphere, planetary in scale, appearing to be connected to the sun's surface by luminous filaments of energy. Imagine the complexity of interpreting such data, images that seem to show something entirely unexpected. For many observers, it resembled a scene from science fiction, suggesting an unknown object interacting directly with the solar plasma. Yet the true nature of stellar mechanisms leads us toward a much deeper and more technical understanding of how light and magnetism behave on such immense scales. Can you imagine the pressure and motion within the sun's layers, where hydrogen and helium are forged under crushing gravity? What many referred to as the black sun is, in reality, a reminder that our perception is limited by the instruments we use to interpret cosmic phenomena. The data itself is real, captured by advanced technology, but the mystery lies in how we interpret what we see. The most accepted scientific explanations suggest that this was not a solid or artificial object, but rather a complex interaction between magnetic forces and cooler plasma. This might seem hard to believe, but solar plasma can behave in ways that appear impossible from our perspective here on Earth. The sun's magnetic fields twist and stretch like enormous elastic bands, creating structures capable of trapping plasma within darker cavities. When these cavities form against the intense brightness of the solar corona, they can appear as dark, spherical shapes, creating the illusion of something foreign within the sun itself. Understanding this teaches us that the solar system is also a place of physical illusions, where light and shadow can challenge our ability to interpret reality. Can you imagine the work of scientists who spend years analyzing these datasets, trying to distinguish between processing anomalies and entirely new natural phenomena? This case shows us that even specialists can be challenged by observations that do not immediately fit into established models. There is no evidence of artificial objects extracting energy from the sun, but the mere existence of such visually confusing phenomena is proof that our star still holds secrets within its turbulent interior. The sun is not simply a stable lamp in the sky. It is a living laboratory of high-energy physics where the unexpected is always possible. Feeling the depth of this knowledge allows us to understand why the solar system is not entirely safe. It is governed by forces on a scale we can barely comprehend. The same magnetic interactions that create these dark structures can also unleash solar storms toward Earth, affecting our technology and daily life. Understanding these mechanisms is a matter of survival. We must study every pulse, every filament, and every magnetic anomaly to protect our fragile island of life. This might seem hard to believe, but our dependence on the sun is as absolute as our incomplete understanding of its deeper behaviors. Now imagine those luminous structures connecting the dark sphere to the sun. What looked like a kind of umbilical cord was, in fact, plasma flowing along invisible magnetic field lines. It is a powerful demonstration of gravity and electromagnetism, working together to shape matter into forms that challenge our imagination. Exploring this idea reveals how thin the line is between scientific explanation and perceived mystery, often defined only by the limits of our observational tools. Can you imagine the humility required to accept that even our most advanced space cameras can produce optical artifacts or uncertain interpretations? Science is not built solely on answers, but on continuous questioning in the face of the unknown. The black sun phenomenon is a perfect example of how physical reality can surpass fiction, presenting us with events that, while natural, carry a sense of grandeur and mystery that invites quiet contemplation. As we move through these technical layers, we begin to feel the texture of the universe itself. The sun is a physical object, made of atoms and governed by laws we can calculate, but its scale is so immense that it will always find new ways to surprise us. The anomalies observed in 2012 and 2016 are just chapters in a book we are still learning to read. Each new observation refines our models and deepens our understanding of the engine that sustains our existence. The safety of the solar system depends on this knowledge. The more we understand the sun, the less vulnerable we are to its natural variations. This might seem hard to believe, but the sun's atmosphere is significantly hotter than its surface, one of the many mysteries that physics still seeks to fully explain. Phenomena like the black sun exist within this broader context of scientific uncertainty, where extreme heat, intense magnetism, and colossal gravity converge. The physical laws we experience daily are pushed to their limits. Recognizing this boundary helps us understand that the solar system is a place of unimaginable power, a domain where energy flows in quantities that make life on Earth a delicate and remarkable exception. Can you imagine the silence in control rooms when a new solar anomaly is detected? It is a moment of respect, of attention, and of searching for answers. The dark history of the solar system is written in these moments, when light becomes shadow, and the familiar becomes strange. The fact that real scientific records can generate such deep discussion is proof of the vitality of our pursuit of knowledge. We do not need external threats to feel the mystery of the cosmos. The sun itself, with its eruptions, cycles, and anomalies, provides more than enough. As we conclude this passage through solar phenomena, the mind remains calm and attentive. What once appeared dark and threatening reveals itself as an expression of nature's complexity. The black sun is not an external object, but a shadow shaped by the sun's own grandeur. In uncovering the truth behind these observations, we strengthen our connection to science and to the physical reality that surrounds us. The journey continues, and each step toward understanding is a light we ignite within the vast darkness of the unknown. After understanding the anomalies that pulse within the heart of our sun, I invite you now to travel along the invisible and silent paths that exist between worlds. Can you imagine space not as a calm and empty void, but as a slow-motion shooting gallery where trillions of fragments of rock and ice move at speeds that defy our biological intuition? This might seem hard to believe, but the solar system we inhabit carries a history written in collisions and deep scars, revealing that our sense of safety is, in truth, just a quiet interval between monumental events. To understand this, we don't need to look only at the distant edges of the universe. The evidence is etched into the very surfaces of the celestial bodies around us. Can you imagine the silence of the moon, that silver world that accompanies our nights? Every crater across its surface is the record of a real impact, a testament to the fact that the solar system is not a stable environment, but a dynamic and occasionally violent one. While on Earth, erosion and life itself erase the marks of the past, the moon preserves a detailed history of bombardments that lasted billions of years. Feeling the weight of that history allows us to understand that impacts from asteroids and comets are not just mathematical models or science fiction narratives, but real events that have shaped the evolution of life and geology throughout our cosmic neighborhood. This might seem hard to believe, but Earth itself has experienced mass extinction events caused by visitors from deep space. Can you imagine our atmosphere, what we now feel as a gentle breeze, being transformed into an inferno of heat and dust within minutes due to the impact of a single massive object? Around 66 million years ago, a rock the size of a mountain ended the age of the great reptiles, altering the global climate for centuries, and proving that planetary balance is fragile in the face of celestial forces. These collisions reshaped the path of life and serve as a reminder that the solar system operates on timescales where catastrophic events are simply part of its natural behavior. Let us now understand how this reality manifests in the present day. Even in an era of advanced technology, constant observation of the skies reveals unsettling truths. Today, thousands of near-Earth objects are carefully monitored by space agencies, yet the sober reality is that not all of them have been detected. Can you imagine the pressure of knowing that smaller objects, still capable of causing severe regional damage, may be moving silently toward us, hidden by the sun's glare or the darkness of space? The darker side here lies in the fact that the solar system is chaotic on geological scales. What we call stable orbits are, in truth, paths that can be altered by subtle gravitational influences, sending comets and asteroids inward on long-term collision courses. You might not realize the sheer amount of debris drifting within the asteroid belt between Mars and Jupiter, or in the distant Oort cloud at the edge of the system. This material is the leftover from planetary formation, pieces that never became part of the main structure and now wander as potentially dangerous nomads. Understanding this motion teaches us that the space between worlds is an active environment. As we explore this idea, we realize that the safety we feel is based on the statistical rarity of large impacts. But rarity does not mean impossibility. The solar system is, at its core, a violent environment where gravity constantly redistributes matter, sometimes gently, sometimes with devastating force. This might seem hard to believe, but small space rocks enter our atmosphere every single day, burning up as shooting stars we admire in the night sky. They are a constant physical reminder that contact with the outside is continuous. Yet the true mystery emerges when we consider the larger objects we have not yet discovered. Can you imagine navigating a map that still contains vast blank regions, where kilometer-sized bodies may be traveling silently for thousands of years before crossing our path? Science works tirelessly to transform the unknown into the known, but the vastness of the solar system ensures that mystery will always have somewhere to hide. With each new discovery of a potentially hazardous asteroid, our understanding of chaos deepens. In physics, chaos does not simply mean disorder. It refers to systems where small initial changes can lead to drastically different outcomes over time. A minor disturbance in the orbit of a distant comet, perhaps caused by a passing star or the gravity of a giant planet, can begin a journey that ends in an impact millions of years later. Feeling this connection between the small and the vast helps us understand why the solar system is not the safe harbor we once imagined, but rather a cosmic ocean of complex currents and unpredictable tides. Can you imagine the effort required to deflect one of these objects if a real threat were identified? Humanity has already conducted impact tests to explore whether we can alter the trajectory of a space rock, revealing our desire to protect life on this small blue world. Yet even with such efforts, the scale of the universe remains dominant. The dark history of the solar system teaches us that catastrophic events are part of celestial mechanics. They reshape surfaces, deliver water to new worlds, and occasionally reset the course of biology. It is a majestic and indifferent process, where geological time is unconcerned with the fragility of the beings who observe it. Let us now return briefly to the Kuiper Belt, which we discussed earlier, and consider it as a reservoir of mysteries and silent threats. From that distant region, long-period comets begin journeys that can last centuries, moving toward the warmth of the sun and crossing the paths of the major planets. This might seem hard to believe, but each of these icy travelers carries kinetic energy equivalent to thousands of nuclear bombs. Understanding this reality should not bring fear, but a sober sense of awe at the magnitude of the forces shaping our home. We are part of a living system where matter is constantly in motion and transformation. Can you imagine the patience required to scan the night sky, searching for a tiny point of light moving differently from the fixed stars? That is the boundary between safety and discovery. Every asteroid catalogued is one less unknown in the equation of our future. As we move through this knowledge, we begin to see that the dark history of the solar system is also the story of our awakening as a species, one that becomes aware of its place in the cosmos. We are not merely passive observers. We are thinkers striving to understand the rhythms of a system that, while chaotic, still follows laws we can learn to interpret. As we absorb the calm of this narrative, we begin to see that the beauty of the universe lies in this balance between order and chaos. The solar system offers us a spectacle of apparent stability that allows us to dream and create, while its deeper nature keeps us attentive and humble. The scars on the moon, the fossils on Earth, and the countless objects crossing the darkness are all chapters of the same story. Looking toward these dangers teaches us not only about the cosmos, but about our own resilience, and about the importance of protecting the only place that, for now, shelters us so generously. This journey through impacts and orbital chaos prepares us for an even broader understanding of the galactic environment. What we have learned about rocks in our neighborhood is only the beginning. Ahead lies a perspective that will take us beyond the solar system itself, into regions where light barely reaches and where new kinds of threats may exist. We continue with calm awareness and sharpened curiosity, understanding that every discovery, no matter how unsettling it may seem, is a vital step toward knowledge and peace beneath the stars. Expanding our perception beyond the boundaries that protect our system, I invite you to feel the vastness of our galaxy, the Milky Way. So far, we have explored internal shadows, solar anomalies, and the risks posed by rocky bodies within our cosmic neighborhood. But now, we must understand that we are not an isolated island in the deep void. The solar system is immersed in an active and dynamic galactic environment, where the harmony we perceive is constantly influenced by invisible neighbors and forces operating on a scale that would make any planet seem like a grain of sand. Can you imagine navigating an infinite ocean where, beyond the waves we can see, there are colossal underwater currents and silent nomads drifting through total darkness? This might seem hard to believe, but our galaxy likely contains millions of black holes, and most of them are not fixed at the galactic center. They wander alone after the violent deaths of massive stars. To understand this extremely rare but real risk, we must first grasp the nature of these nomads of darkness. When a star with a mass many times greater than our Sun exhausts its fuel, it collapses under its own gravity, compressing an enormous amount of matter into an incredibly small point where density becomes extreme. The result is a black hole, an object that emits no light and cannot be seen directly, because its gravitational pull is so strong that not even photons can escape. Can you imagine such an object traveling silently through interstellar space for billions of years? These wandering black holes are like cosmic ghosts. They do not shine like stars or reflect light like planets. They simply exist, distorting the fabric of space and time as they move. The chance of one passing directly through the center of our solar system is, fortunately, extremely small. But science reminds us that the probability is not zero. And what makes this possibility unsettling is not only the idea of a direct encounter, which would be catastrophic beyond description, but also the gravitational influence such an object could exert even from a distance. Now feel the weight of gravity as an invisible web connecting everything that exists. If a black hole were to pass relatively close to the outer regions of our solar system, it would not need to collide with anything to create chaos. Its mere presence could disrupt the delicate orbits of objects in the far reaches, such as those in the Kuiper Belt or the Oort cloud. Can you imagine the Oort cloud, a vast spherical reservoir containing trillions of icy comet nuclei surrounding the solar system like a fragile shell? These objects are held by a very weak gravitational bond to the Sun, and any massive external disturbance could break that balance. This might seem hard to believe, but the passage of such an invisible nomad could dislodge these trillions of icy bodies, sending showers of comets toward the inner solar system. What was once a region of quiet stability could become an avalanche of projectiles moving toward the planets. This connection between the galaxy and our home teaches us that the solar system is not protected by walls. We are part of a larger ecosystem, where the movement of an unseen mass billions of kilometers away could influence the fate of entire worlds. Let us now reflect on the idea that the universe is not static, but a dynamic and evolving galactic environment. We often imagine the stars we see in the sky as fixed points, but in reality, all of them, including our Sun, are in constant motion around the center of the Milky Way. Along this journey, we pass through regions of varying density, move near other stars, and occasionally encounter the remnants of stellar evolution. Feeling this vulnerability should not disturb our calm, but deepen our respect for the immense scale of physics that governs our existence. The fact that we are here today, in a stable environment that allowed life to emerge, is a testament to the vastness of space that most of the time keeps such dangers at a distance. Can you imagine the patience required for the light of a distant star to travel thousands of years before reaching our instruments, carrying information about the environment we inhabit? The search for wandering black holes is one of the greatest challenges in modern astronomy. Because they emit no light, scientists must rely on gravitational microlensing, rare events where the gravity of an invisible object passes in front of a distant star, bending and amplifying its light like a cosmic lens. It is through these subtle signals that we detect their presence. This might seem hard to believe, but each of these discoveries reinforces the idea that the solar system is a traveler moving through a territory that has not yet been fully mapped. We are not protected by complete isolation, but by the vastness of distance. The dark history here lies in recognizing that we live not just in a local neighborhood, but within a galactic forest filled with mysteries and powerful forces. Understanding the existence of wandering black holes, even as a low probability risk, helps us appreciate the temporary stability that the sun provides. Feel the internal pressure that gravity exerts on every atom in your body, and recognize that this same force, on a scale trillions of times greater, governs the motion of black holes across the galaxy. Reflecting on this connection allows us to feel linked to the birth and death of stars. A wandering black hole is, after all, the remnant of a once brilliant star that now drifts as a dense and silent memory. They are guardians of the deepest secrets of matter, regions where the physical laws we know begin to break down. The vulnerability of our solar system in the presence of these invisible giants reminds us that safety is a perception based on the present moment, while the universe operates on deep time. Science allows us to glimpse that deep time and anticipate the connections that may shape our future. Understanding the potential effects of wandering black holes is to recognize both our fragility and our greatness as beings capable of conceiving such phenomena from a small rocky planet. Can you imagine the silence of a gravitational encounter between our system and one of these nomads? There would be no sound, only subtle and relentless changes in planetary orbits, shifts in tides, and a new choreography for distant comets. It is a reminder that we live in a universe that is sovereign and indifferent to human concerns. Yet within that indifference lies a quiet beauty, the beauty of universal physical laws that apply equally to a falling leaf on Earth and to the motion of a black hole thousands of light years away. As we conclude this passage through galactic influences and hidden dangers, our understanding expands. We no longer see the solar system as a closed environment, but as part of a vast, interconnected whole, magnificent, and at times unforgiving. The mystery of wandering black holes prepares us for the next step in our journey, where the silence of the cosmos will reveal an even deeper perspective on life and survival. We continue with a calm mind, grounded in the understanding that every new discovery, no matter how unsettling, brings us closer to comprehending the universe we inhabit. Now that we have traveled through monumental scales of physics and the invisible threats that wander through our galaxy, I invite you to shift your focus toward a deeper and more strategic dimension of our existence. So far, we have spoken of mass, orbits, and colossal energies, but there is a mystery that is not only astronomical, but also cosmological, and profoundly connected to our nature as conscious beings. Can you imagine the absolute silence of the universe, not as an absence of life, but as a signal that something far more complex is unfolding in the shadows of deep space? This might seem hard to believe, but the fact that we have never detected a clear sign of extraterrestrial intelligence may actually be one of the darkest indications that the solar system is not as safe as we would like to think. Let us now explore the dark forest theory, a fascinating and sobering hypothesis that attempts to explain the great silence of the cosmos through a logic of strategic survival. Imagine a dense, dark forest at night, where countless hunters move silently among the trees. Each one must remain extremely cautious because they do not know who else is out there, whether others are friendly or hostile, or what resources they possess. In such a forest, any sound, any broken branch, or any flicker of light could attract the attention of an unknown predator. Therefore, the most rational and safest behavior is to remain completely silent. hiding one's presence at all costs. Can you imagine our galaxy as this immense forest, where every civilization is a hunter trying to survive in uncertainty? This idea is built on three simple assumptions. First, that the universe may be filled with civilizations. Second, that resources are finite. And third, that it is impossible to know the true intentions of others. This might seem hard to believe, but under this logic, the safest strategy for any advanced civilization is not to seek contact, but to remain hidden. Feeling the weight of this silence invites us to reflect on our own history as a species. Whenever a technologically advanced civilization encountered a less developed one on Earth, the results were often devastating for those who were discovered. When we apply this perspective to the cosmos, we begin to see that our existence may carry a statistical risk we are only beginning to understand. For decades, humanity has been sending signals into space, radio waves, light, and probes, like a child shouting in a dark forest, unaware of who or what might be listening. Can you imagine the fragility of our position if the dark forest theory reflects reality? The absence of detected signals would not mean we are alone, but that others are wise enough not to be found. Cosmic silence would no longer represent emptiness, but rather caution, strategy, and perhaps fear. In this view, to exist and be detected could be a death sentence for a civilization, transforming the act of broadcasting signals into a potential risk to the safety of our solar system. Exploring this idea leads us to question the missions we have already sent beyond our neighborhood, such as the Voyager probes, which carry golden records containing our location and culture. These were sent with a spirit of curiosity and peace, yet the logic of the dark forest suggests we may be revealing too much. This might seem hard to believe, but our desire to be seen could also be our greatest vulnerability. The safety of the solar system may depend not only on stable orbits or a calm sun, but also on our ability to remain discreet in a potentially hostile universe. Feel the weight of this possibility and notice how it changes the way we look at the stars. Each point of light could be the home of a civilization watching in silence, deciding whether we pose a threat or are simply irrelevant. The dark forest theory does not claim that hostile beings are actively seeking us, nor that danger is imminent, but it transforms the meaning of the cosmic silence we observe. The void becomes filled with possibilities, some of them uncertain, some of them unsettling. Can you imagine the shift in mindset required for humanity to decide collectively to reduce or even cease its transmissions into space? This is a question that touches on ethics, survival, and the long-term future of our species. At this point, the discussion of cosmic safety becomes deeply personal. We are no longer speaking only of rocks, gravity, or distant phenomena, but of choices we make as a conscious civilization. Our curiosity is one of our greatest strengths, but in a dark forest, it may also carry risk. This might seem hard to believe, but many respected scientists and thinkers have warned about the dangers of actively attempting contact with unknown intelligences. They suggest that the silence we observe may be evidence that discretion is the norm and that noise is the exception, and potentially a dangerous one. Understanding this perspective helps us see why the solar system could become a target if our signals reach the wrong listeners. The vastness of space, once seen as protection, becomes the medium through which our presence can travel. Allow yourself to reflect on these ideas calmly, in a space of quiet thought. The dark forest theory teaches us that knowledge is our greatest defense, but that knowledge also includes knowing when not to be seen. It is a lesson in humility, suggesting that reality may be far more complex and competitive than our optimistic visions of space exploration often assume. Can you imagine a civilization that has remained silent for millions of years, simply observing others like us? This possibility invites us to reconsider our place and behavior on the galactic stage. The solar system is our shelter, and protecting it may also mean becoming guardians of our own signals, of what we choose to reveal and what we choose to keep hidden. Every signal we send into space today may travel for thousands of years, reaching systems we have only begun to map. As we conclude this reflection on cosmic silence and survival, we are left with a sense of quiet respect. The beauty of the stars carries with it mysteries that may shape our long-term destiny. The dark forest theory stands as the fifth of our dark mysteries, preparing us to look toward the future with greater awareness and care. The journey continues, and each step we take in understanding these possibilities brings us closer to navigating a universe that is as magnificent as it is uncertain. As we begin to reflect on what lies ahead in the distant future, we must first expand our perception of what the future truly means in a cosmic context. Can you imagine the solar system 1,000,000 years from now, or perhaps 1 billion, when the constellations we recognize today will have completely shifted, and Earth itself will have undergone transformations beyond anything we can fully grasp? The future of this story is not a simple path of progress, but a journey shaped by risk trends, technological innovation, and the inevitability of physical laws operating across immense spans of time. This might seem hard to believe, but the sense of safety we value today is only temporary, a delicate balance that nature, in its indifferent majesty, is under no obligation to preserve. Let us now explore how advancements in astronomy and physics are reshaping our relationship with tomorrow. The future of our investigation into Planet 9, for instance, may soon transform what is currently a gravitational mystery into a directly observed reality through new generations of powerful instruments. Can you imagine pointing a telescope capable of detecting the faint residual heat of a hidden world trillions of kilometers away? In the coming decades, the mapping of our solar system is expected to reach such precision that there will be fewer and fewer places for massive objects to remain hidden. This progress will not only satisfy our curiosity, but also allow us to calculate orbital dynamics with unprecedented accuracy, reducing uncertainties about the long-term behavior of celestial bodies around us. And yet, the future also carries the same statistical risks we have explored. Technology evolves, but chaos as a property of physics remains unchanged. This might seem hard to believe, but mathematical models projecting planetary motion millions of years into the future suggest that the solar system may not be as stable as we once assumed. Even small instabilities in Mercury's orbit, for example, could amplify over vast timescales, potentially leading to collisions or even the ejection of planets. These are not immediate dangers, but they are real possibilities embedded in the mechanics of gravity. Can you imagine a civilization responsible not only for monitoring planetary climates, but also the stability of an entire star system to ensure its survival? As we consider the future of asteroid and comet impacts, we encounter a landscape of both risk and innovation. In the near future, humanity may develop planetary defense systems capable of deflecting objects that pose direct threats. But the deeper lesson remains. Large impacts are rare, but inevitable over long timescales. The solar system continues to send visitors from distant regions like the Oort cloud, many of which have not yet begun their inward journeys. Understanding this cycle invites us to shift from passive observers to active guardians of life. Can you imagine autonomous systems positioned across the solar system, prepared to intercept wandering objects before they can alter Earth's environment? We must also consider the long-term future of the Sun itself. The same star that sustains life today and produces phenomena like the black sun follows a life cycle governed by nuclear fusion. Billions of years from now, it will expand into a red giant. This might seem hard to believe, but the inner solar system will eventually be engulfed in extreme heat, transforming the surfaces of planets we now consider stable. Feeling the scale of this transformation reminds us that nothing in the cosmos is permanent. The sun will shift from a life giver to a force of transformation, and the solar system as we know it will cease to exist in its current form. This is a process so distant in time that humanity itself may have evolved into something entirely different before it unfolds. Looking outward again, the future also includes our journey through the galaxy. As the sun orbits the center of the Milky Way, completing one revolution approximately every 225 million years, we pass through regions of varying density and encounter different gravitational influences. These journeys may bring us closer to molecular clouds or stellar remnants that could subtly disturb the structure of our system. Advances in gravitational wave detection may one day allow us to hear these movements long before they become significant influences. Can you imagine humanity listening to the gravitational symphony of the galaxy, anticipating the approach of unseen masses drifting through space? When we return to the implications of the dark forest theory, the future presents a profound ethical and strategic dilemma. As our detection capabilities improve, we may begin to identify signs of life, or even technology, around distant stars. But with that ability comes increased visibility. The more we observe, the more detectable we may become. Can you imagine technologies designed not only to explore space, but to conceal our presence within it? The future of our safety may depend not only on knowledge, but on discretion. Allow yourself to feel the calm of contemplating these vast horizons. The future teaches us that safety is not the absence of danger, but the expansion of our ability to understand and respond to it. Each technological advancement becomes a tool that helps us navigate a universe that is both dynamic and, at times, unforgiving. When we think across millions of years, we begin to feel the texture of deep time, where life persists not by chance alone, but through adaptation and awareness. This might seem hard to believe, but even our biology may evolve as part of this journey, adapting to different gravitational environments or existing within protected habitats beyond Earth. The future is not something that simply happens to us. It is something we are actively shaping through curiosity and understanding. The dark history of the solar system will continue to unfold, revealing new anomalies and solving old mysteries, but its essence will remain unchanged, a vast laboratory where gravity governs and life seeks its place. Can you imagine a future civilization that looks at the sun, not with uncertainty, but with complete understanding of all its mechanisms? That is the ultimate goal of science, to transform mystery into knowledge. The future shows us that while the solar system may not be entirely safe, our intelligence and adaptability are forces that can bring balance. We are not merely passengers on this blue world. We are becoming conscious navigators of a system that still has much to teach us. As we conclude this reflection on the future, we recognize that it is a natural extension of everything we have learned about the past and the present. The risks are real, but so is our capacity to respond. The dark history of the solar system is, in many ways, a story of resilience. And with that understanding, we move calmly toward the final stage of this journey, where science meets reflection and knowledge becomes quiet awareness. As we reach the final moments of this journey, I invite you to gently gather everything we have explored and allow it to settle into a calm and steady understanding. We have traveled through invisible giants, solar anomalies, ancient collisions, wandering black holes, and the silent logic of the cosmos itself. And perhaps, more than anything, we have come to understand that the solar system is not defined by absolute safety, but by balance. Can you imagine the quiet elegance of a system that exists on the edge of stability, where countless forces interact in a harmony that is never fixed, but always evolving? What we often perceive as permanence is, in reality, a temporary alignment of conditions, an agreement between gravity, time, and motion that allows life to exist, at least for now. This might seem hard to believe, but the very fragility of this balance is what makes our existence so extraordinary. Every stable orbit, every calm solar cycle, every moment of silence in the vastness of space is part of a continuous negotiation between forces that could, under different circumstances, lead to entirely different outcomes. And yet here we are, aware, observing, and capable of understanding. As you reflect on Planet 9, you begin to feel the quiet presence of the unknown shaping the edges of our system. As you recall the black sun, you recognize that even the brightest source of light carries shadows we are still learning to interpret. The impacts remind us that transformation is written into the fabric of time, while wandering black holes reveal that even the emptiness between stars holds hidden movement. And the dark forest theory invites a deeper awareness, that survival may depend not only on knowledge, but on wisdom. Can you imagine the perspective of stepping back and seeing all of this not as a collection of threats, but as a vast, interconnected system of processes? The solar system is not a place designed for comfort. It is a dynamic environment where stability is earned through balance, not guaranteed by default. And in that realization, there is no fear, only clarity. Feel the calm that comes from understanding. The same forces that carry risk are also the forces that created everything we know. Gravity, radiation, motion, time. These are not enemies, but fundamental elements of a universe that is both powerful and consistent. The more we understand them, the more we learn how to exist within their rhythms. This might seem hard to believe, but knowledge itself is one of the most powerful forms of protection. Not because it removes uncertainty, but because it transforms uncertainty into awareness. And awareness allows us to respond, to adapt, and to continue moving forward, even in a universe that does not promise stability. Now, allow your thoughts to slow down. Let the vastness of space become something gentle, something quiet. The mysteries we explored are not here to disturb your rest, but to deepen your sense of connection with the cosmos. You are part of this system, not separate from it. The atoms that form your body were shaped in the same processes that govern stars and planets. Can you imagine the continuity of that idea? That the same laws guiding distant galaxies are present within you, in every breath, in every moment of stillness. There is a quiet harmony in that realization, a sense that even within uncertainty, there is belonging. As we conclude, remember that the solar system may not be perfectly safe, but it is profoundly beautiful, deeply structured, and endlessly fascinating. And within it, we have found a rare and delicate space where life can pause, observe, and understand. If this journey brought you a sense of calm curiosity, consider continuing to explore with us at Cosmos for Rest, where science and stillness move together. Now, rest. Let your mind drift gently, carried by the quiet rhythm of the universe.